students, you are on to Dr. OJ's tutorial. In this video, we shall discuss the inverse trigonometric functions. We are going to use an example to illustrate what we've learned previously in inverse trigonometric functions. Don't forget to click on the notification bell so that each time I upload new video, you'll be duly notified. Thank you. And let's look at an example. Example 1. Example 1. Show that arctan x is equal to arc sine x all over the square root of 1 plus x squared. Show that arctan x is equal to arc sine x all over the square root of 1 plus x squared. How do we show this? We want to transmit from x to alpha. Let's say that let arctan x is equal to alpha. We assume this arctan x is equal to alpha. Alpha is a constant. You can use any other thing. So by the time you multiply through by tan x or tan, you multiply these two sides by tan, you have what? Multiply tan inverse of x by tan, you have what? X equals to tan alpha. Just multiply the two by tan. Okay. Now recall, we previously learned that alpha is equals to sine inverse over sine alpha. I hope you can still remember that. Which is same thing as cos inverse of cos alpha, which is same thing as tan inverse over tan alpha. You can still remember that. We've learned that in our previous class. Okay, so we express sine alpha in terms of x. So to express sine alpha, let's now express sine alpha in terms of x. To express sine alpha, now we shall express sine alpha in terms of x. Okay, we introduce alpha as a constant. So what do we do? Right, if you can still remember vividly, you have cos x square alpha, in our trigonometric identity is equals to 1 plus cot square alpha. Can you still remember that? Fine. So, which implies, this is the same thing as 1 plus, and cot square alpha, what does that mean? Cot square alpha means what? Cos square alpha all over sine square alpha. That is what? That is what that means. That is what that means. Cot square alpha all over sine square alpha. I hope you are getting that. Fine. So, now how do we now express, cos square alpha in terms of x? That's a question for us. That's a question for us. Now, we virtually know that, if x is equal to, like I've just said now, tan alpha, tan square alpha will be equals to x squared. I hope you understand. So this, we can go this way, and at the same time, we can even say that it makes it easier by saying, because we already know that x equals to tan alpha. Okay, we can go through this. And so, you can say 1 plus cot square alpha is equals to 1 all over tan square alpha. So instead of splitting cot square alpha to be this, we can go this way, because we have already known that x equals to tan alpha. So this one will now be what? This one will now be 1 plus 1 all over, because tan alpha is equals to x. So tan square alpha will be what? X squared. I think that is better instead of going through these. This will be longer, and it can also create more problem for us. Okay. Now with that, we have gotten what? Cos x square alpha to be equals to 1 plus 1 over x squared. So if we evaluate this, LCM of this is x squared. So all over 1 in x squared is 1. 1 times 1 is 1 plus x squared in x squared, that's 1. 1 times 1 is 1. Oh, sorry. 1 in x squared is x squared. This will be x squared. Okay. Plus x squared in x squared, that's 1. 1 times 1. Sorry about that. So we have x squared plus 1 whole over x squared. So that is so we have gotten this to be what? This is now what? That is cosec square alpha is what? X squared plus 1 all over x squared. Okay. Now with this, if we find the inverse of this, you can actually know that cosec square alpha is same thing as 1 all over sine square alpha. Yes, because cosec alpha is 1 over sine alpha. So cosec square alpha will be 1 over sine square alpha. Okay, I hope you are getting that now. So now, if we find the inverse of this, it means that I want to find the inverse of 1 over sine square alpha. So which will give me what? I will now have what? Sine square alpha will be the inverse of this what? S square all over S square plus 1. What I've just done is I found the inverse of 1 over cosec square alpha. I found the inverse of this. So find the inverse of both sides to give us that. Okay. Now to get sine alpha out, we find the square root. The square root of sine alpha will be what? The square root of x squared all over s squared plus 1. Okay. Now, which implies that. Let's clean this. Which implies that. So alpha here will not be what? Alpha will be sine inverse. That is, by the time you find the sine inverse of both sides, alpha will not be sine inverse of what you have here. That will be sine inverse of x squared all over s squared plus 1. So you can write it as alpha equals to sine inverse of x all over the square root of s squared plus 1. And remember, when we started, we said, let tan inverse be equals to alpha. So with our assumption, so we now replace alpha with, therefore, tan inverse of x is equal to what? X sine x all over the square root of x plus 1. So that is that about that. So we are through with that. That is as simple as that. So let's look at more questions still on trigonometry. Let's look at more questions still on trigonometry. But this time around, we'll be discussing about trigonometric equations. So trigonometric equations. So in the next video, we shall illustrate very relevant example on trigonometric equations. So don't forget, once again, click on the notification bell so that each time I upload a video, you'll be duly notified. Thank you.